Hello, we are going to be demonstrating the laws of momentum using these two marbles, which are of approximately equal mass and equal weight. So these two will collide with an they're going to collide, and then the collision can be calculated.
Alright, so since the two marbles collision was an elastic collision, or at least mostly elastic, we can write the equation as m1v1 equals m2v2. So we measured out the marbles' masses, and we measured the velocity of the marble during the collision. So I'm going to write them down as 1 gram and 0.5 and 0.05 meters per second. The mass of the other marble, since they are the same type of marble, is going to be the same, so I can write down 0.001 kilograms again. So these two will cancel because they are the same weight, so when you divide them out, we'll get the same thing. So in the end, the velocity of the second marble is going to be equal to the velocity of the first marble, which makes sense because it's an elastic collision.
So the marbles gave us an example of an elastic collision. The water bottles, on the other hand, because of what they're made of, they're going to give us more of an inelastic collision. So when I take this one water bottle and I give it X potential energy due to gravity, it's going to hit this one and they're going to kind of stick together, but not quite so much. So the data is not going to be quite lining up, but the concept's still the same. So when I let it go, they stick together, and if you notice, it went about halfway as from the original. But the concept's still the same. So when I let it go, they stick together, and if you notice, it went about halfway as from the original.
Alright, so since the collision with the water bottles was an inelastic collision, you use a different formula for it. In this case, it is E equals MA BA, and that being the first water bottle. In this case, it's one which we will be releasing and pulling back to hit the second water bottle, plus MBVB over MA plus MB. The reason why it's like this is because the water bottles will stick together, or at least mostly will stick together due to it being an elastic collision. So when we plug these in, V equals, we weighed the water bottles and found the speed of it, so the mass of it is 0.318 kilograms, and the speed of it was 0.3 meters per second. Plus 0, because it has no velocity, it's a stationary bottle, and then divided by 2 of 0.318. Because the water bottles are the same, it's just easier to write like that. So when you take the velocity of this, you divide it all out, and you get 0.0151 meters per second. Which makes sense because you're having two of the same thing, so your velocity would be about halved.
So this principle is the reason why when a smaller object and a larger object collide, if the larger object is the one that is moving, the smaller object's velocity after the collision will be greater than that of the original velocity of the larger object. If they stick together and it's an elastic collision, then they will both move slower together. Now when a smaller object hits a larger object, you get a completely different result, which looks a little bit like this. so for momentum, we can determine the amount of energy that is, oh crud,